Hello guys, this is Prime Concept. Now we want to consider in this video JUPEB 2025 Physics Practical. We want to look at the practical physics that was handled by JUPEB just yesterday. 2025. Yesterday's date should be, I think, 14th, right, of 2025. So we want to look at that practical and analyze it for the sake of those that will be writing the same exam next year. And they will be bringing more videos concerning their practicals and every other thing, physics, theory, chemistry, and mathematics. So the exam has a circuit diagram like this. That is the first part of the exam, which is the electricity. This is the circuit diagram that was given, right? And they provided a battery with EMF. So the EMF of the battery that was provided was 3 volts, right? So you have an ammeter to measure the current. You have X, which is a standard resistor whose value was not revealed to them. So, but then I'm going to tell you what to do about this. Then we have a variable resistor, or you can use a resistance box for this so that you can vary the resistance of this circuit, right? Now, what I'm going to do in this video, I'm going to teach you how we can arrive at our table of values for this particular experiment, even without carrying out the experiment. And in one of my further future videos, I will be performing the experiment. But right in this video, we want to look at under exam condition when you have limited time, or you get to exam hall and maybe one of your instruments is not working very well. Say your ammeter is not functioning very well and you don't have an option. So one of the things you need to know is, how do you generate your table of values even without performing the experiment? So that is the concept I'll be using in this analysis, which is actually a very, very simple circuit analysis, right? Now let's read through the procedure. I don't have enough space, so I'll just read through the procedure if you're following. Now the procedure says you are provided with a standard resistor X, which is this, a resistance box R, which is this, connecting wires, these things are connecting wires, an ammeter, which is this, a key, which is this, a key is just a switch, right? And a battery, which is this. So the battery EMF is 3 volts, which is mentioned in the question. And they say connect the circuit as shown in this figure. The second part of the instruction says set the resistance box R, which is this, set it as R equals 2 ohms. So it means the first experiment you do, you would be using R as 2 ohms and close the key. So when you close this key, now current will begin to flow through the circuit. Then you can take your current reading. Read and record the value of current I on the ammeter. So when you close this key and this resistor is 2 ohms, you close this key, you check the value you're getting on your ammeter, then you record it. That is if you are performing the experiment, right? Now, the second part of the next part of the question says evaluate R inverse. So they want you to evaluate R inverse. Now, if you notice, in this particular year, in other years, they used to provide a table. You just fill your table. But in this particular year, no table was provided. So it means that from reading the procedure of this question, you should be able to tell or generate your table, tell the parameters that should be in your table. Now, one of the things you would notice is that the parameter that is varied in this experiment is your R. So when you want to create a table of values, there are 3 things you need to have in mind. One is the parameter that varies throughout the experiment. That is one of the first things that should be in your table. So I want to create my table. So I would have first my serial number, which is the first thing you have. Then secondly, the parameter that varies in the course of the experiment. So they told us that R will be changing. That is why you have this. This is a variable resistor, which the first value is 2. The next value you would see from the procedures 4, 6, 8, and 10. So the quantity that is varying is R. That is the next thing, which is measured in ohms. So you include your units. Now the next thing is, they say we should evaluate R inverse. So the next thing that comes on your table after the varying quantity are the calculated and measured quantities. So they asked us to measure I. So I'm going to place I next as my measured quantity. It should come next in amperes. Then after your measured quantity, which is I, the next is your calculated. So what are the three things that should be on your table? Your varying quantity, your measured quantity, and your calculated quantity. So they asked us to calculate R inverse. So this is a calculated quantity which is measured in per ohms. So these are the three things that should form our table. Now, they gave us the values of R. The first value is 2. Now, you don't have to put ohms again because your R is already measured in ohms. So you just write 2. That is why the unit is here. The next is 4. The next is 6. The next is 8. And then finally 10. So these are the values we have on our table. So we want to carry out this experiment and then find out what the values of I would be. Now, without performing this experiment, we can use simple circuit technique to find out what this would be. So what are we going to do here? Since we want to measure the current, this is the total current. Assuming this ammeter was placed in this place, it would mean that you want to find out the current flowing through only this resistor. Assuming this current was placed here, you want to measure the current flowing through only this resistor. But because this ammeter was placed here, it means you want to measure the total current. So whenever you want to find total current in a circuit, first you'd understand that these two resistors are in parallel. So what will their equivalent resistance be? So we're trying to generate a formula we can use to find I, even without performing the experiment. So follow me keenly and the concept will be clear to you. Now, our equivalent resistor, when you have two resistors in parallel, your equivalent is simply going to be their product, which is X times R. So their product over their sum, then X plus R. So this is the equivalent resistance when you have two resistors arranged in parallel. So if I have this, I'm going to now have an equivalent circuit that follows Ohm's law, so that I will have that E, which is the voltage, is equal to the total current I times the total resistance R equivalent, which is actually XR over X plus R. So this is what I would have. Now remember, I'm trying to find I, so I would make I the subject, right? So if I make I the subject, I would have that I is going to give me, I would be equal to X plus R all over XR into E. So this is the formula I can use to find I. Now, they said X is a standard resistor, which we, under your exam condition, it will be sealed. That's why it is X, so that you won't know the value, because the secret to the experiment lies in X. But then, for your electricity experiment, your standard resistors always range between 1 ohms to about 6 or 5 ohms. So most of the times they give you 1 ohms or 2 ohms. So, but in this particular one, what they gave was actually 2 ohms. So you would always be safe using your standard resistor to be 1, 1.5 or 2 ohms. Now, they won't judge you because your school, since they didn't specify which one, your school might provide 1 ohms for you without you knowing. So at the end of this experiment, our graph is going to reveal which one we use. So you don't even have to be worried, because I will show you at the end of this experiment how you can now tell, because they are trying to find out which value of X you use without you knowing. From our graph, I will reveal the secrets to you. So we're going to use X. We're going to use X as 2 ohms for this experiment. So let's do our first calculation. When R is 2, let's find out. When R is 2, let's find out what our current would be. Our current, I think I'm going to rub this side because of my space. Do I still need the diagram? I don't think so. I'm going to rub everything here. So now we want to find out our current when for R equals 2. What would our current be? Our current I, using this formula, remember that we already said X. We're going to take X as 2 ohms. So it's going to be 2 plus 2 all divided by 2 times 2, right? Into our EMF is given in the question, which is 3. So if I solve this, let me quickly punch this. I would have this 4, okay, 4, which is actually 3. So this is going to still give me 3 ampere. So I have 3. I don't have to put ampere. Now you repeat the same thing when R this time around is 4 ohms. Your current I is going to be what? It's going to be 2 plus 4, all divided by 2 times 4 into 3. So if you also solve this, you will get, I've done this somewhere, so let me get the values. So if you also solve, you will get I to be 2.25 amp, right? And the next, you're going to solve for R equals 6 ohms. So if you do this, you're going to find out that your I is going to be 2 plus 6 divided by 2 times 6 into 3. So if you do this, you're going to get 2.00. So if you continue this process, you're going to arrive at the values for your current. So this, I would say 0.00. This, I would say 2.25. Then this, I would say 2.00. The next one is 1.88. The next is 1.80. So this is what we have as our current. So this is what you're expected to get if this is what you're using. So even if you had done this in your exam, you'll be very correct. Very correct. So this is the correct result. Now, for our inverse, we have 0.500, 3 place of decimal. 0.250, 0.167, 0.125, and then 0.100. So this is what our table of value would look like. So this is what our table of value for this particular experiment would look like, right? So if you got values like this, you are correct. So you can still try out using X as 1. If you get those same values, you'll still be correct because they expect that X can vary within that range, right? Now, so this is what we have. Let's look further to see other things they asked in this particular experiment. Now, they said tabulate your readings, which we have done. I'm going to plot this graph in my next video, so I won't make this video very long. The next video, after we have answered these questions, I'm going to now plot the graph. Tabulate your readings. Plot a graph of R inverse. Plot a graph of R inverse on the vertical axis and I current on the horizontal axis, starting both axes from the origin. So we want to plot a graph of this against this. So determine the slope of the graph. Now, before I even plot the graph, I can actually show you what you expect your slope to be. And this is where most students get it wrong. When you join my physics class, for those of you that are already part of my students physically, you would understand one of the things I teach in my physics class is before you even plot your graph, what do you expect your slope to be? How do you know the outcome before you even finish? Which is one of the things I'll show you. So before we even plot this, I can tell you the expected slope. So let's go through that process together. So I'll draw this. Now, they say we should plot a graph of R inverse on which axis? Y axis, and then I on X axis, right? So this is what they want us to do. So when you're plotting graph of this on the Y axis, it simply means from our equation here, we're going to try to make 1 over R or R inverse the subject formula. So if we try to do that, we would have, let me go through this now. we would have from here, from this particular equation, I'm going to cross multiply. So I'm going to have E into x plus r to give me I, x r. So this is what I have. Remember, my aim is to make 1 over r the subject. This is x, this is not times, so I'm sure you're aware. So if you expand this is going to be ex plus er equals I x r, right? Now, if I push this to come and meet this, I would have ex equals I x r. When this crosses, it becomes minus er. So I have ex equals, what is common on this side now? You notice that I have ix minus e into r. So r is common, right? So that I will take r to this side and then bring ex to the other side. So if I do that so that I don't waste time, I'll divide both sides by exr. So I'll divide all through by exr by exr. So that if I do this, this would go, right? Then I'm left with 1 over r here, which is going to be, this would also go. So I'll be left with ix minus e divided by what now? Ex, right? Yes, so that 1 by r is going to give me what now? It's going to simply give me, if I divide, you notice this can go. Let me still separate. Ix divided by ex minus e divided by ex. So this is what I would have. I'm going to rub from the start. Okay, let me rub. So finally, I would have 1 by r equals what now? X can go, right? So I would have 1 by e times I. That's what I have here. Minus, you notice that e can also fizzle in, minus 1 by x. So this is what I have. Now remember, I'm plotting a graph of 1 over r. 1 over r is still same thing as r inverse. So I'm plotting a graph of 1 over r against current. If you compare this to equation of a straight line, which is y equals mx plus c. If you compare this to equation of a straight line, you would notice that your slope, since you're plotting 1 by r on the y-axis and you're plotting I on the x-axis, it simply means m, which is your slope. Your slope is going to be 1 by e. Now, what is the value of e? We know the value of e. They gave us in this question. So the value of e is actually 3. So it means that my slope is going to be 1 divided by 3. So, and when you do 1 divided by 3, you get 0.333. So it means your slope should be around 0.333. Your slope should be around, when you have plotted this graph in this particular exam and your slope is far from this value, it means that your answer is wrong. So your slope should be around 0.33. So if you get 0.32, you are correct. 0.34, you are still correct. 0.31 is still acceptable. So your slope should be around this. So if in this particular exam you got something around this, then just go and relax because you've passed it. It's very correct. Now, the next thing I want to show you, they said determine the slope of the graph and intercept. Again, you will now see where the secret lies. If you compare this, of course, you know that C here represents intercept. So what is your intercept theoretically supposed to be? Your intercept, which is C, is supposed to be minus 1 by x. So that if you make x the subject in this case now, so that you can see that your intercept is actually the negative of 1 over that unknown resistance or resistor, which they did not allow you know from the beginning. So it means that from here now, those marking will now know if your answer is correct, right? Because they expect that you should get that same value that you use. So that if you want to know, you can simply say that x is going to be minus 1 by c. So what this thing simply means is that when you plot this graph, your intercept is expected to be negative. Now, without plotting this, having seen this, what shape will my graph take? I'm going to show you very quickly. Having seen this is how I expect my graph to be. My intercept should be negative, my slope is positive. So, of course, I expect that my graph will go this way. It will cut somewhere around the negative y-axis, right? So this is what I expect my graph to be. It's going to go this way, not this way, not a curve, a straight line cutting through the negative y-axis. So it means if you understand this concept and you're trying to plot this graph, it would mean that you will need to create space below your negative y-axis so that when you are plotting graph, you can accommodate. Some students make this mistake, and if you make this kind of mistake under exam condition, it may delay you, right? So, but if you can analyze your graph even before plotting, you would know that you have to create space here. While some persons may jump and just start plotting and they won't create any space here, they just start everything from this point. No space below, no space to the left. So with this, you know that you need to create space below. So I believe this concept I've explained here is really very clear to you. The next question said, evaluate 1 over your slope. Of course, what are they trying to do? 1 over slope. When you evaluate 1 over your slope, it should give you 3 volts, the EMF. That is what they want you to do. So in order for you to understand this, in my next video, I'm going to plot the graph, then use my graph. Using this table of value, I'll use them to answer these other questions that follows this. So I believe this is really very clear to you. If you enjoyed this video and you are yet to subscribe, please hit the subscribe button because I'll be dropping more videos on practicals, theories, right, that will benefit you. Do well to like my video, comment, and share with 10 of your friends so that they can also benefit. Tell them this is Prime Concept.